So for this talk, I'll be talking about flying blind. And in the last one, we talked a bit about how APIs are becoming very important in modern software development life cycles. And there are so many APIs today. Every modern critical business application is dependent on APIs. So how does API services, the building blocks of your system you're talking about, the visibility into it is very important, and how flying blind won't really help you to get to a ideal security posture everybody is looking for. So yeah, I think I don't need an introduction. That's a bold statement, but I just introduced myself half an hour back. Cool. So what business demands? Business demands the rapid, responsive, reliable, innovative system. And when we talk about rapid, responsive, and reliable systems, it's hard to build these 3 Rs. But nobody cares about how hard it is, or nobody cares about how much time it will take to build a rapid, responsive, and reliable system, right? Business wants it now. So then when business wanted the rapidity, the responsiveness, everything in a system, the technology has given cloud DevOps, IoT, mobile applications, microservices, APIs, agility, cloud native, all these fancy words, right? And everything help us to get to a stage where we can deliver the responsive applications and the innovative applications as soon as possible. So microservices provide us the flexibility to build, release, and deploy the services separately, move faster as independent teams or independent service ownerships, and get to a production as quick as possible. So, but as technology delivered, it also created some problems. So APIs are at the heart of innovation, as we're talking about, and most of the digital businesses, most of the modern businesses rely on APIs. They are becoming the building blocks and interfaces for the modern applications. And you can build, it has unlimited potential. You can build as complex application as possible using these building blocks. So few of the customers we are working with, some of the large enterprises, some of them are like very like mid-market, some of them are like 2-3 years old startups. So we have even seen people using 10,000, 20,000 APIs in production. That is like very lean, but then even there are few of those you having 100,000 API, and some of them are shadows, some of them are actually like old versions which are still there, and a lot of problems exist as an ecosystem itself. But the crux is APIs provide you the interfaces. APIs provide you a lot of potential to create the modern applications which are responsive, and you build them as soon as possible. So we evolved from building the bespoke monoliths, like there's data, business logic, user interface in a single application, single service, to having a cloud-native microservice-based application which has UI, then there's a business logic, then there's separate data layers, and everything spread across different layers, right? So the modern microservice applications might even have 100, 200,000 microservices. So yeah. And when you look at the Death Star diagram for Amazon or Netflix, this is how the microservice architecture looks like. Like as in, there are so many services and connections, each service is talking to each other, and then at the end you get a very complicated connection layer. And having this complicated connection layer, securing this connection layer is hard, because you don't even have observability into that layer which can penetrate and give you visibility to the APIs and help you find these connections as soon as possible. So what are the challenges we faced as the API economy evolved, as we are building this API-first, microservice-based, distributed applications? Some of the important challenges are everything is business logic, and breaks pretty quickly with some of the edge cases. Then the API context propagation is hard. Maintaining that context is hard. The data exposure is one of the problems, and there's a continuous changing APIs, continuously changing services as per the customer requirements, as per the business requirements, and business requirements are evolving rapidly as well. Then there are internal threats, external exposures, API proliferation, shadow APIs, which I was talking about. Some of the organizations have 10,000, 20,000 APIs, but they are not even using some of the APIs as a shadow APIs. These APIs are not being called, these APIs are not being used in any of the services. But as the API specs are not updated, nobody knows about the specs, nobody knows about these APIs, and they still exist. They can be one of the attack surfaces, major attack surfaces for the attacks as well. Then troubleshooting problems associated with this modern microservice-based applications is hard, considering so many layers, so many connections which exist, right? Then there are dependencies everywhere. Every service is dependent on 10 other services. Every service is calling 10 other services. So to drill down, what are the 4 challenges, or what are the 4 core questions when it comes to any modern distributed application? So are the services or APIs providing the functionality they were designed to deliver? Are the services or APIs secure? As a business, do you understand the uses of the APIs by users? And are the services or APIs you are providing have the optimum performance for the user? So these are the 4 questions we'll try to address with the various angles. And so to solve these challenges, various things you need to do as a business. And first, we'll drill down to problem. We'll understand some of the core problems associated with this, and then we will see how we can solve the challenges and the problems associated with the whole stack. So first is dependencies, which I was talking about. In the modern microservice-based distributed application, there are so many dependencies. The thousands of services talking to each other. There is no end-to-end visibility into dependencies in this architecture. Then understanding of the failure point is your first step in debugging, but understanding the failure point itself is harder because when the failure starts, it has cascading effects, and you have to go to origin of it, which might be 10 layers, 20 layers, 30 layers down the line. Then it's difficult to decipher the connected metrics between the services. And once we narrow it down to a particular service group or narrow it down to a particular part of your architecture, you try to find the hotspot. You try to find, for finding a hotspot, there are multiple Grafana dashboards. We're trying to correlate the metrics between different services. We are trying to do a context correlation between these different dashboards, and it involves a lot of context switching, going to different dashboards to understand metrics for different services, and being able to correlate them is hard. And again, at the end, it's a cognitive load on the developer side of things, because they are the ones who have to do this manually. They are the ones who are doing this in their head. Then debugging slow queries. So if user faces a problem, the developers or the DevOps people, DevSecOps people manually log the slow queries into logging system. Then dependencies on DBAs hit. You have to talk to a DBA to get the slow query logs, and the whole process becomes very slow and tedious. So even the performance impact is huge in this case. And the log fatigue, right? So whenever some problem happens, I found a hotspot, now I'm drilling down, I find out, and I found out like 1,000 line of logs. I'm trying to go through these logs. I'm trying to understand what broke. I'm trying to understand what failed. And it's hard to correlate this sheer amount of logs, and the sequential navigation to figure out the root cause is pretty hard. So let's just go through a simple example of the incident, and then we can go through what are the solutions, how we can address these problems. So let's assume everything is visible in the browser. And so there's an apizone.com, and it's a web and mobile application. It has hundreds of different services. There's login, search, shipping, inventory, payment, order tracking. Consider a normal e-commerce application, right? So it has, this is how the architecture looks like. And so now there's this URL. And you're trying to check out with one particular item in your cart. In this case, there's a TV, and you just change one parameter for discount, added a value 99.22, and you got 99.22% discount on this particular item. So many of you might think that this is not possible in the modern scenarios, right? Like, people at least protect this kind of things. But then, when you look into reality, there are so many incidents which happened in recent years around the very basic concept of mutating these parameters. People are able to mutate these parameters, change these parameters to the expected values they want, and they can just exploit the applications. It's getting very easier as the attack surfaces are broadening. Even you can access your neighbor's detail by just using changing the customer ID. If all these things are open, if all these things are not protected very well, and first, to protect all the parameters, to protect all the APIs, you first need to know what exists in your system. So in some of the cases, if this is a shadow API or the older version of API which is out there, nobody ever tried to just got that version out and have the latest version out there. So at this older version, even this older version of API can cause the problem. And if there's no conformance analysis in place, then it will be a huge issue at the end. So yeah, so if you don't know your entities, if you don't know what APIs are being used, if you don't know what services, what APIs exist in your system, you're basically flying blind when it comes to security. Because at that point, you are securing the company, you're not trying to securing the granularity at assets. And securing your assets ultimately leads to securing the org, ultimately leads to securing the application. But understanding your assets, understanding your APIs is important at this layer. And then, so how do you solve for the API security then? So first and foremost important step is you get to observability layer where you actually know the connections, you actually know the dependencies, you actually understand the architecture of a system. And that's where in the last talk you're talking about, right? The knowledge gap between developers and security professionals. So this whole context of how the system works, how the system has been written, what interactions are allowed, what interactions are not allowed, how this particular API or service should be interacting with other set of services or APIs. Is this version of API valid or not? Is this a shadow API or not? Is this API is being used or not or called somewhere? All these details are something you'll get out of the observability part of things. And then having a security focused logic on top of it definitely helps you to do a better job at securing your assets in a better way. So yes, there are 4 steps to stop flying blind. And the first is know your application DNA. Know the components, know the connections, know the context. And as in the last one, we saw that writing OpenAPI spec, maintaining OpenAPI spec is hard. So have a right set of OpenAPI specs, and so have a tools which will help you maintain them very well, keep them updated, have a conformance analysis in the pipeline. So one of the case studies from Vodafone India. So Vodafone had a huge breach in recent years, especially in the India itself, where a lot of customer data was leaked, and that was purely due to one of the older API versions which was out there, and they never had a conformance analysis in place. So eventually they got a pipeline for conformance analysis, figured out, and now that they are running the whole conformance analysis, API security testing in their CI/CD pipelines. So theoretically, they have been able to save a lot of reputation and money in the recent years. So this components, connections, and context matters. Then adopt a continuous mindset. So changes can't avoid change. Changes, everything is changing every day. So as per the customer requirements, as per the product requirements, your application is evolving. But at the same time, and again, the novel threats, the new sophisticated attacks are coming in every day. The machine learning AI boom is there. People want to solve everything with machine learning and AI. But at the same time, you have to have this continuous mindset where these evolving applications, these evolving requirements, these changing applications need to be protected. So integrating all this security tests, integrating all this security checks, gates we have in mind into a continuous CI/CD pipelines will help you protect yourself in a regular fashion. So, and the third one is preparing for rapid response. So most of the times, talking about last time as well, it's more of a, when it comes to security incidents, we have more of a reactive response and proactive one. And even in the reactions, because of lack of context, it's mostly slow. So whenever an incident happens, we don't know the cascading effects because we don't have that whole end-to-end dependency chart and dependency observability. And then the alerts which are coming in, the investigations which are happening, even for alerts, right? Whenever something starts failing, you get bunch of alerts from bunch of services, the different tools. And being able to correlate these alerts, being able to correlate this to the layer and figure out a layer of a system which is impacted by this is the first step to get to a stage of solving for this particular problem. Then investigating it, monitoring continuously, blocking the right attack vector, blocking the right set of requests helps you to rapidly respond to the alert and minimize the damage. Then most of the organizations think developer, security, and ops as a separate teams because again, there's a clear job separation in the title and in job description as well. But then unless and until all of these teams start working together very well, it's very hard. So developers being a big bunny here, they write a lot of APIs, they write a lot of code, write a lot of services, but then at the same time, security teams should continuously find block threats, have the proper checks control gets in CI/CD pipelines. Then ops teams should continuously check for the deployments, the compliance, and all the other aspects of it. And all of the teams working together as one team, trying to solve one particular problem, that is making your system secure and reliable, will help you to get to a better stage and avoid flying blind as well. So, as this is end of my second talk, already finished. So they asked me to run for 30-35 minutes at least. And yes, so little bit of marketing at the end. So this we do all three things. We have a API catalog as a service which basically uses agents, traffic mirroring, uses a live traffic of your application to create a live API catalog of your product. And so you get to know all of your APIs, all of the risk scores associated with your APIs. Then the RASP and WAF of the world, the protection provides you real-time anomaly detection, blocking, and then the analytics give you the way to slice and dice into your traces, your request, analyze, find the attack vectors, block what you want to block, or get to a stage, get to a granularity where you want to find the right request parameters. So, yeah, that is it. And so few more, yes, that is it from my side. And sorry for the little bit inconvenience on this one. I have to prepare it for last minute. So yeah, so that is it from my end. And yes, stop flying blind. Know your assets, know your services, know your APIs before you start protecting them. And yes, if you have any questions, please feel free to ask them. Yes, go
ahead. Thanks, Jayesh. What are your thoughts on API gateways in terms of observability and consolidating security?
Yep, so definitely API gateways are one of the most important ones when it comes to larger customers as well, right? So we have many customers who are purely doing this observability layer on the API gateway itself. So we are protecting APG, WAF, all. So basically having a observability at API gateway gives you access to a lot of context which can be utilized very well when it comes to security problems. So triaging security problems or like analyzing some of the vulnerabilities becomes very easy if you have a right set of observability, right set of metrics and traces specifically at a API gateway layer. So logs are a little nuanced. It's hard to correlate, it's hard to go through the logs at that layer, but Tracers definitely help when you are talking specifically around API gateways. Yes. Any other questions? Yeah.
So on, yeah.
Sorry, I didn't get the last part.
What is your policy that you recommend or practices or rules to set from AppSec team to talking with the dev team to ensure that you set up the correct rules to detect these anomalies and pick them up firsthand? Yeah.
Yeah, so mostly, so what we follow ideally is the security team defines the uh, requirements from their end to development team itself. So we have a proper set of tools which are running, like there's a SAS analysis which runs via Sneak, there's a DAS analysis which runs via Stackhawk, now via Traceable itself. So having all these tool sets in pipeline and security team setting up the proper policies, like we shouldn't have this set of critical vulnerabilities, like maybe 10, if you have 10 critical vulnerabilities, including SQLi, including BOLAs, in this particular scan, you should be fixing it before we release it to the next customer, or before we go to a next release. So having those kind of control gets communicated prior to the design stage becomes makes it very easy for even for developers to understand these KPIs, right? So if you have a security specific KPIs well defined and communicated to a development team, that helps a lot in many cases. And even for policies specifically regarding to anomaly detection and stuff, right? So most of the anomaly detection happens in real time, so you can't really get developers to, because it won't happen in a development stage. But even whenever the anomaly is detected, communicating it in a right way to developer, in a way they can understand, and then getting them to make right changes, again set of KPIs around SecOps should be helpful.
Well, thank you, Jayesh, for
Sure.
talking to us twice today. We're very happy to have you. Thank you so much.